Welcome back to my YouTube channel. In the course of this video lesson, I'll be solving different practice questions that cut across different topics in chemistry. Now let's get into the first practice question, and it says, when a bottle of Coca-Cola is opened, bubbles of gas evolve. The gas is. Now, this question is extremely very easy. What they are asking us to determine here is to determine the gas that is evolved, is to determine the gas that is given off to the surrounding. Because whenever we hear the word a gas being evolved, it means that that gas is given off. It means that that gas is released to the surrounding when a bottle of this drink called the Coca-Cola soft drink is opened. So which gas is evolved whenever a bottle of Coca-Cola soft drink is opened? It is very easy. The gas that is evolved, the gas that is given off to the surrounding whenever a bottle of Coca-Cola soft drink is opened is called carbon dioxide. It is not carbon monoxide. Carbon monoxide has its chemical formula to be CO, but for carbon dioxide, its chemical formula is CO2. Are you following me? This is the gas that is evolved whenever a bottle of Coca-Cola soft drink is opened. Not this. This gas is a toxic gas. This is the gas that is produced from the exhaust pipes of cars and as well as generators. So you can say that this is the gas which is called carbon monoxide that is, produced or evolved whenever a bottle of Coca-Cola soft drink is produced. That's not possible. The gas that is actually evolved is carbon dioxide. And this gas, which is carbon dioxide, is what is responsible for the fizzy nature of this soft drink, which is called the Coca-Cola soft drink. That sound you hear whenever you open a Coca-Cola soft drink. That's the fizzy sound, and this is the gas CO2 that is responsible for you to hear that sound. It is not sulfur dioxide. This gas is used as a preservative, and it can be hydrogen gas. Hydrogen gas does not have any business to do with, soft drinks. I believe this question is clear. It is very easy. Now let's get into the next practice question. So let's get into the second practice question, and it says, sodium and potassium belong to same group of the periodic table. This is because, now this question is extremely very easy. When I look at this question, I actually know the topic to which this question is from, and it's from the topic in chemistry which is called periodicity, talking about periodic table. So before we actually even go to each of the options to analyze the options and then get the answer, it is important for me to explain to you the concept of the periodic table. It is very important to know that. So how does this periodic table work? Now, currently we have about 118 elements in the periodic table, but more elements are still being discovered. But in explanation, like for me to explain the concept of the periodic table, I can't just start writing the 118 elements here on the board. So I'm going to use the first 20 elements to explain to you the overview of how the periodic table works. So listen carefully so that we can now then come to the options and analyze each of them to get the question. Okay, it's very simple because they are telling us that sodium and potassium belongs to the same group. I don't know. We have to check. You understand? So this is how it works. Let's draw the periodic table for the first 20 elements. It's very simple. So we'll start with this. We'll start with the elements, which is H, hydrogen. The next element is helium. The next element is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium. K is potassium, and lastly calcium. You can see we've written out the first 20 elements. So let's arrange them properly. So this is how it works. We're going to put, like, put them in boxes, which I'm doing now. Just watch. It is very, very easy. Okay, watch closely. We do this as well. We do for these guys. We do for these guys. Put them together. All right. And the last one we do for these guys as well. Now we are not done. Let's use line to separate them horizontally, which I'm doing now. And then now we are okay for now. So moving further, there is another thing you must know about the periodic table. You must understand here that in the periodic table, or the periodic table in general, is divided into two parts or two components, which are the groups and also what we call the periods. So these are the two major components of the periodic table in chemistry. We have what we call the groups and also what we call the periods. The groups are the ones that are vertical, whereby the periods are the ones that are horizontal. We call the groups vertical columns. Hold on, I'm going to explain. So moving further, what did I say we call the groups? We'll call the groups vertical columns. All these are columns, you understand, whether all of these are rows. So the groups are the vertical columns, whereby the periods are the horizontal rows. Are you following me? It's very, very simple. We have about 8 groups in the periodic table. Okay, this is just on basic understanding. We have about 8 groups, which are, I'm going to write them up here. This is group 1. These are the group 1 elements. These are the group 2 elements of the periodic table. These are the group 3 elements. These are the group 4 elements, group 5 elements, group 6 elements, group 7 elements, and lastly group 8 elements, or if we don't call them group 8, we call them group O elements. Are you following me? It's very simple. Whereby for periods, there are so many. Okay, we can't just tell you that we have a specific number of periods, because there are still more elements to be discovered. But in the first 20 elements, let's count out the period. I told you periods are horizontal. So we have period 1 element, we have the period 2 element, we have the period 3 element, and also period 4 element. So for the first 20 elements, how many periods did we get? We got just 4 periods. So it's the understanding of this periodic table that will help us solve this question. It is very, very easy. Now, moving further, this must be noted. It must be noted here that the elements inside this periodic table are all arranged in order of increasing atomic numbers. You can see the word number. These numbers are counted serially. They are counted orderly. This is what I mean. Increasing atomic number means that hydrogen has its atomic number to be 1, and its atomic number is located down. So hydrogen atomic number is 1, helium atomic number is 2, lithium is 3, barium is 4, boron is 5, carbon is 6 atomic number, nitrogen is 7, oxygen 8 atomic number, fluorine is 9, neon is 10 atomic number. I believe you are still both, whereby sodium is 11, magnesium is 12, 13, 14, 15, 16, 17, 18, 19, and 20. So you can see we've written out the atomic numbers of the first 20 elements. I said that they are all arranged in order of increasing atomic number. Now, moving further, let's get back to our question and read the question. They told us a statement in this question. They said that sodium and potassium belongs to the same group. They are telling us a statement. And I think what they're not saying is, why is it that sodium and potassium are in the same group? That's why they're saying this is because, here are the options. I'm not going to read the options here. Let's analyze first. So let's check if this statement from sodium down to periodic table is correct, that sodium and potassium belong to the same group. So we've analyzed everything. These are group 1 element, group 2 element, group 3, 4, 5, 6, like that, up to group 8 element or group O element. So let's check. This is sodium, this is potassium. Wow, they are correct. Sodium and potassium belongs to the same group. I'll mark that good. That statement is correct. So they're not asking me, why is this so? Why is it that sodium and potassium are in the same group? Very simple. But before I tell you the reason, I have to list out the names of these groups for you. It's very important in case you see to exam. So you must know here that group 1 element, they have their names. They are called alkali. They are called alkali metals. These are what we call group 1 elements. whereby for group 2 elements, they are called alkali earth metals. Group 3 elements, we call them earth metals. Group 4 elements, we call them the carbon family. Carbon family. Are you following me? It's very, very important you note all of these. Group 5 elements, which you are seeing now, the group 5 element, there are still more elements, but this is just for the first 20 elements. They are called nitrogens. The P is silent. You understand? We pronounce that as nitrogen. Group 6 elements, they are called the chalcogens. Chalcogens. The group 7 elements, okay, which you are seeing here, fluorine, chlorine, like that, iodine, bromine, astatine, tennessine, they are called the halogens. If we don't call them halogens, we call them salt formers. These are the elements that like forming salts, you understand? And for the group 8 element, we call them aerogens. If we don't call them aerogens, we can as well call them noble gases. So this is another name for them, noble gases. Okay, if we don't call them noble gases, we can call them inert gases. Inert gases, meaning that they don't like reacting. And lastly, we can call them real gases. So these are the possible names for these group 8 elements, also called group O elements. I believe you are following me. And these are the names of those groups of elements. It is very important you note this. This is very, very important because we have to progress there to solve this question. Now, moving further, there is something I have to tell you before we can start reading these options, because it's not just good for me to just tell you the answer that this is the answer. It is important for you to know why the answer is the answer. That is why I'm taking my time to explain every single concept about the periodic table in just a little few minutes, so we can then go and choose the answer to the question. It's simple. So then we've established all of these. Now, this must be noted about groups. Let's talk about these groups. Like, there are some things that are common to each groups of the periodic table. Now, take note. Elements in the same group have the same chemical property. This is very, very important. What does this mean? It tells us that elements in the same groups, like you can see group 1 element, lithium, hydrogen, sodium, potassium, for group 2 element, beryllium, magnesium, calcium, they have the same chemical property, means that they behave alike. And why is this so? That would be the question you ask yourself. Why is it that they have the same chemical property? It's very, very important. It's very, very easy. This is due to them having same number of valence electron. Wow, this is very, very important. This is due to them having what? Same number of valence electron. What is this valence electron I'm talking about? This is the electron that is seen in the outermost shell of an atom. It's very simple. I'm going to show you what I mean by that. Okay, it is very important to note all of these. These things are very key. Now, moving further, I believe you've written down all of these groups and their names, because I'm going to explain what I mean by what I just said now. Okay, so moving further, let us progress. So let's let's work on the group 1 elements. I want to work on lithium and sodium. Lithium is Li. And what's the atomic number? 3, whereby for sodium it is Na11. All right. So now let's draw the shell rotation of these elements using the atomic number, because that atomic number is also called the proton number. Yes, because I believe you already know that these are atoms, and all atoms have 3 important subatomic particles. Any atom at all in chemistry have what we call 3 important subatomic particles, which are proton, electron, and neutron. I call them pain. And these numbers down, they are called atomic number. And I just told you that these atomic number are also called proton number. And for an atom that is neutral, proton number always equals electron number. So automatically, this is my proton number to be 3. For sodium, it is 11, but they are all neutral. They are not without any charge. If here was plus or here was plus, then it's going to be charged, then we will not be talking about what I'm saying now, but they are not charged, then my proton equals my electron. So it's proton number for lithium is 3, electron number, proton number for lithium is 3, the electron number is also 3, proton number here for sodium is 11, electron number is also 11. I already have a full video lesson on this where I explain how to determine the proton, electron and neutron number for an atom. So moving further, let's draw the diagrammatic representation. Now this is an atom. You know, all atoms have nucleus. All atoms have nucleus here that is centrally located, and this is my first shell. The first cycle you draw is your first shell, and it's called the K shell. In the topic quantum numbers, I already have the video where I explain on quantum number, understanding all of these shells. You know, everything you have to know about quantum numbers is already on my channel. The link will be in the description of this particular video. And the first shell occupies a maximum number of 2 electrons. Take note, 2 electrons, whereby any other shell to be drawn should occupy a maximum number of 8 electrons. Okay, so now we've drawn 2. How many remaining? 1 to make it 3. So then I'll put 1. You understand? So you can see at the outermost shell I had 1 electron. So the valence electron here for lithium, valence electron for lithium is equal to 1. And let's check for sodium. The first shell occupies 2 electrons, the other shell should occupy 8. I just said that. 2, 4, 6, 8. You understand? So in general, I'm having 10. 2 plus 8, that's 10. So how many do I need to complete 11? So I need 1 more. You understand? So at the end of sodium, during sodium shell notation, what was the valence electron? The valence electron for sodium is 1. You understand? Since it is 1, then you can see that lithium and sodium, they have the same number of valence electron. As they having the same number of valence electron, this is why all elements in the same group have the same chemical property. If you check for group 2, their valence electron will be 2. There are little tricks you just need to know them, but it's important for you to check. But just know that all elements in the same group have the same number of valence electrons. This is why they will possess the same chemical property. I believe you are following. It is very easy. So we've established that, all right? So let us progress. There's one last thing I have to explain before we go back to the option to understand and solve the question. Is very easy. I'm going to talk about the electronic configuration of elements in the same groups. It's very, very simple. You know, we have what we call electronic configuration, and that's what I'm about explaining right now. So it's important for you to listen carefully before we can go ahead to talk about electronic configuration and then answer the question. Now, moving further, this must be noted. You know, for we to successfully write what we call electronic configuration, we have to understand a principle in chemistry called the Aufbau's principle that explains the build-up mechanism of atoms. All right, it's very simple, and this how it is. It's called the Aufbau's principle. Aufbau principle. All right, so listen carefully. This how it works. Aufbau principle is also called the build-up principle, and look at this. Let me just write out some stuff out. 1s. You know, it talks about orbitals, and we have different orbitals in chemistry. We have about the s orbital, the p, the d, and the f orbital. There are other orbitals as well, but these are the major orbitals. So we use that to write. So I'm writing 1 to 7, 1s, 2s, 3s, 4s, 5s, 6s, and 7s. So after I'm done with the s, I'm going over to the p orbitals. Are you following me? And I will start from 1p. I'm going to start from 2p. This is how it works. It's very simple. 2p, 3p, 4p, 5p, and then 6p, 6p, and 7p. So after p is the d orbital, I'm going to start from the here. You understand? 3d, 4d, 5d, 6d, and 7d. And the last is f. So I'm going to write here, start from here, 4f, 5f, 6f, and 7f. You understand? And pull lines down to direct them. You can see the way the line is coming. You can see the way the line itself. So stop there. If you still go like this, you still have something like this. It's not 7s it's passing through. It's passing through 6s. You understand? It's very simple. Okay, so we pass through 6s. So now, listen carefully. Now, the question you asked me, why am I writing all of this, is going to help us understand what we call electronic configuration. Because you have to understand what this means. Electronic what? Configuration. So now, let's go back to, you know, sodium and potassium. It's very simple, all right? Now, if you observe, in this question, or in this periodic table, sodium and potassium were in the same group. For sodium, sodium is actually what now? Na11, and potassium is K19. So you can see that sodium atomic number is 11 and potassium atomic number is 19. So what's my proton number for sodium? As I explained previously, it is 11. Proton number for potassium, 19. What's the electron number for sodium? 11. What's the electron number for potassium? 19. I told you they are all the same for neutral atoms. So this must be no sense. So how do we write electronic configuration? It is very simple. We have to understand that all of these are orbitals, and these orbitals have maximum number of electrons that they can occupy. But for the s orbital, it is 2 electrons maximum it can occupy. For the p orbital, it is 6. For the d orbital, it is 10. For the f orbital, it is 14. They all have difference of 4 if you observe it carefully. So there is a reason I'm doing this. I have to explain this on the topic quantum number. It's important for you to go check out that particular video lesson. Now, moving further, let's progress. Electronic configuration. Now, let's quickly write out the electronic configuration for sodium and potassium. I will start with sodium, which is Na11. It's simple. Electronic configuration is EC is going to be equal to you can say the word electronic. So what do we use to write electronic configuration? It is simply electron number. So we've agreed that the electron number for sodium is 11. The electron number for potassium is 19. So let's quickly write for sodium. So how are we going to do that? We'll start with this principle. We'll start with this orbital. They call it 1s orbital. So right here, 1s. What we are working towards to get 11. All these are possible questions that can come out in your exam. So it's important for you to note all of these. So 1s is the first. You understand? So what's the maximum number of electrons that should be in the s orbital? 2. So 1s2. We are fighting towards getting 11. So 1s2 was the next. 2s. 2s, and what's the maximum number that can enter the s orbital is 2. So 2s2. Please take note, you don't start with 3s, you start from up down, up down. So when you're done with 2p, you enter 3s. When you're done 3s, you enter 3p down. When you're done with 4s, you enter 3d down. You understand? You're going up down. So what's the next? 2p. So here should be 2p what? Now what's the maximum number of electrons that enters the p orbital? Is 6. So 2p6. Let's be very careful. You can see here that it is 2, 2, 6, that's 10. Because 2 plus 2, that's 4. 4 plus 6, that's 10. So we need one more electron. So what's the next? 3s. So here is 3s what? So, it's still s orbital, so it's 2 maximum. But since, we have to make sure that it's 11, we have to put a 3s1, you understand, to make sure that it's 11. So this is the electronic configuration for sodium. We've written it. Let's write the electronic configuration for potassium now, so we can compare, analyze all we've done to get the answer. I want you to understand very well all of these things. That's why I'm taking my time to solve this question. Now, moving further to potassium, which is K19. What becomes the electronic configuration? Still the same principle. We're using 19 to write. So we'll start using the principle as well, which is 1s2. Definitely s is 2. We are working towards 19. So let's be fast. For the other, which is 2s, so here should be 2s2. After 2s2, what should be the next? 2p. So 2p6. We are trying to get 19. So after 2p6, what's the next? 3s. 3s2. 3s2. After 3s2, what's the next? 3p. Yeah, 3p6. 3p6. We have to watch out so it will not exceed 19. After 3p is 4s. So here is 4s2. You understand? So now let's count to see if we'll get to see if we have to get 19 or if we exceed 19. So here is 1s2, 2s2, 2p6, 3s2, 3p6. So here is 2, 2, 4 plus 6, that's 10. Here is already 10. Wow, that's 20 already. So here I should reduce it to 1. Do you understand? Now, if you observe carefully, you can see that at the end of writing the electronic configuration of both of them ended at which orbital? The s orbital. Are you following me? So this tells us that they have something in common. This tells us that they should be in the same group. Are you there? It is very, very simple. It is not difficult. You understand? We've already seen that they're in the same group. They have the same chemical property. So let's read this question very well. They say sodium and potassium belong to the same group of the periodic table. This is because both are metals. Is that true? That's not true. Because if you observe from what I told you that group 1 elements are called alkali metals, group 2 elements are called alkali earth metals, group 3 elements are called earth metals. So you can see from group 1 to group 3, they are all metals. So is it because they are metals that they're in the same group? No, we have other elements which are metals and they are not in the same group. Do you understand? So option A can never be the answer. Is it because both of them are lighter and softer than water? Yes, they are lighter and softer than water, but that's not the reason. That's not logical. You understand? Option C, both forms cations by losing electrons. Do you think that's true? Yes, both forms cations by losing electrons, but that is not why they are in the same group, because all other elements that are metals forms cations by losing electron. You know, I'm going to talk about this subsequently in subsequent videos, what metals are all about. You understand? Because metals are elements that forms cations, that forms ions by losing electron. But non-metals, they form their ion by gaining electron. So we have other metals that does that. That's not the reason. Option D, both have identical electronic configuration. Are you not seeing that the electronic configuration is identical at the end, that it fell under the s orbital? So they are identical. That is why both of them are in the same group. If we check for other elements, it won't be like that. You understand? So that's why the answer is option D. I believe it is clear, it is very easy. So if you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share my videos with your friends. So get into the next practice question.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the Jamb exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
Moving further, let's get into the third practice question, and it says 1 grams 1 g of an oxide of metal X. What does this information tells us? We have to analyze what this means. Oxide of metal X solution. This question is extremely very easy. Whenever you hear the word oxide of a metal or anything at all, oxide of a metal X, they specified the metal, though the metal was not known, they just told us that it's metal X. So let me tell you what this means. It means that this compound is made up of the metal itself and oxygen. Are you following? It's very simple. If it's oxide of a metal, sodium, it's going to be sodium and oxygen. Or anything at all, it means that there are two elements here, because oxide contains two elements. The word oxide means, but the dominant element is oxygen. Now, moving further, you can see that the question says 1 grams of an oxide of metal. So, the total mass of the oxide of metal is 1 gram. So, the metal and the oxide together, they have a total mass to be 1 gram. So, we take note of this. Of a metal X, atomic mass of the metal is 64. We will need that. Gave 0.8 grams of the metal. So the mass of the metal specifically was 0.8 grams. I believe you're understanding. When reduced with hydrogen. So when we reduce that metal with hydrogen, we have to now split both of the elements, forming the oxide of the metal, which is, the metal itself and oxygen. You understand? So because this question is on determining what we call empirical formula, it is very important. And also, you don't use hydrogen here because I didn't want to say, okay, hydrogen was mentioned, then I need hydrogen. No, hydrogen was just used to reduce the oxide of metal to get the metal itself, which is X, and oxygen. So now what do we do to get, because the mass of the oxygen was not given, but we can determine it to solve the empirical formula. It is very simple. So we've already established that the total mass of the metal plus oxygen will give us 1 grams. So then, how do we now get the mass of oxygen? Simple. We're already given the mass of the metal to be 0.8 grams. You understand? Plus the mass of oxygen, which is unknown for now. So it's equal to the total mass, which is 1 gram. So how do we get the mass of oxygen? Very simple. To get the mass of oxygen, is going to be this 0.8 gram cross the equality sign to become minus 0.8 grams. You understand? So it's going to be 1 grams minus 0.8 gram. So the mass of oxygen becomes 0.2 grams. I believe you are following. So this mass, we then put it under oxygen and then start solving for the empirical formula stated by the question, because they are saying the formula of the oxide is, they are asking us to get empirical formula. Very simple, like ABC. So what do we do? Very simple. Here, I'm going to write first, the first step in doing this, in calculating for empirical formula, is to divide by atomic masses. We were given the atomic masses of these elements already. For the X, metal X, it was given to be 64. So divide by 64. For oxygen, something you should know, also it was given to be 16. So we should write divided by 16. So let's solve. So 0.8 divided by 64, that is 0.0125. So here we're having 0.0125. So let's divide 0 points by 16. We are having the same number, 0.0125. Wow. So the next step is to divide by smallest. So what does this mean? So the answer you have to get, you divide by the smallest. And if you observe, both of them is literally the same. So both of them are the smallest. So divide by any of them, you understand. 0.125 divided by 0.125. I believe when you do this, you have to get 1 as your mole ratio. You do this, you are also to get 1. What does this tells us? It tells us that the empirical formula of this compound becomes X1O1. You understand? And X1O1 can also be written as XO. So this is the empirical formula of the compound. And I believe you can see that XO is the answer to the question. It is very, very easy. Now let's get into the next practice question. Moving further, let's get into the next practice question. And it says, the compound, here is a compound. They are asking us to name this compound. It is very simple. Okay, I already have a full video lesson here on my channel that explains from scratch how to name organic compounds so easily. So go watch that video, all right? But I'm still going to make this particular question very easy, all right? So listen carefully. Now, there are different steps to be taken when you are about naming an organic compound. And one of them is to identify the longest continuous carbon chain. This is very, very simple. This is what I mean. Like you try to look at the compound and try to look at the carbon-carbon connection. But in this case, the element was condensed. This is what I mean. Normally, there are carbon-carbon connection in the sense that you can see here CH3. This height is actually, all right, H is here, H is here, and H is here. They actually condensed everything. I believe you can see the carbon-carbon connection. So let's just leave it the same way. So we already know that carbon is bonding with carbon. You understand? So we have to identify the longest continuous carbon chain in this compound. So we count. So looking at this compound, I can see 1, 2, 3, 4. Wow, I saw 4 carbons when I counted horizontally. So I can also see another chain like this. Let's count 1, 2, 3, 4. This is still 4 as well. All right. So in the look of things, I can just decide to take the horizontal because when I counted like this, or if I count like this, 1, 2, 3, 4, it still gave me 4 carbons. It's telling me that, oh, the longest continuous carbon chain is 4. So if I count horizontally, it's still the same. So let's just take horizontal counting. Not that it is always horizontal counting. Please don't make that mistake. You can count in any direction. So if you see, you can see that when I counted like this, it still gave me 4. And if I name it, it's still the same name I'm to get. I've explained all of this in that video lesson where I explained from the scratch. So go watch that video. The link will be in the description section of this particular video. So what do we do next? After you've numbered the longest continuous carbon chain, after you've identified the longest continuous carbon chain, the next step is to number this chain. And you are numbering in 2 directions. You are numbering forward and also you are numbering backward. This is what I mean. Let's number forward first of all. It's simple. This is my carbon 1, this is my carbon 2, this is my carbon 3, and this is my carbon 4. Let's number backward. This is my carbon 1, carbon 2, carbon 3, and carbon 4. I believe you are following. After we have numbered the longest continuous carbon chain, we saw that we had 4 carbon. This tells us that the parent name of this compound should end with but. You understand? And if you check carefully, you can see that this compound has single bonds. And any compound with single bond, it should be an alkane. So the name should end with A. So this compound is a butane. But we are not done naming it because now, after we've identified all other groups that there will now be a substituent. I believe you are following. It is very, very simple. So you can see that we've named this compound, the parent name to be butane. There are other substituents, and we must make sure that these substituents have a low number as possible. That is why we are counting forward and backward. So when we counted forward, let's look at the forward direction. When we counted forward, we saw that chlorine was at carbon 2. You understand? So we're having 2 chloro. We put that in our mind. Same CH3. This CH3 is a group. They call it a methyl group. Are you there? We don't just, in organic chemistry, we don't call it chlorine. We don't call it 2-chloro. Sorry, we don't call it 2-chlorine. Organic chemistry, chlorine's name will change to chloro. Bromine's name will change to bromo. You understand? Iodine's name will change to iodo. All these have been explained in that video. So we'll watch that video. All right. So it's 2-chlorine. Why is it 2-chlorine? Because the chlorine was at carbon 2. So this same carbon 2, I'm counting forward. Forget about this backward direction. Let's focus on the forward direction. So this same carbon 2, I had methyl. So here is still 2-methyl. You understand now? It is very, very simple. All right. So if you come backward, you can see that it will not be at carbon 3. And is it what we want? No. Want to make sure that the number we are getting for our substrate is low as possible. So we can't use this backward direction because it gives us 3 to be the substrate. That's not what we want. You understand what I'm saying? It is very, very important. Now, there's something you must understand here. You can see that the counting is not always in the forward direction. It can also go back. It just depends on how the compound is structured. You understand? It is very, very simple. So moving further, this substituent we've highlighted from the compound will be added to the parent name. This is the parent name. You understand? And we'll add it to the parent name based on alphabetical arrangement. Yes. So you must know that C comes before M. So write C first. So it's going to be 2-chloro 2-methyl-butane. Now, if you observe what happened, you can see that between numbers and letters, we use dash to separate it. This must be noted. Between numbers and letters dash, numbers letters dash, so this must be noted. So that's the name of this compound. 2-chloro 2-methyl-butane is very easy.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the Jamb exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
So go watch my full video lesson on how to name organic compounds from the scratch, not just alkanes, so many other groups of organic compounds. So let's get into the next practice question, which is question number 5, and it says, how many isomeric forms are there for the molecular formula this? This question is very easy. Now, let me teach you how it's done. First of all, when you say a compound that they are asking you to determine the numbers of isomeric form, what are isomers? First of all, isomers are compounds with the same molecular formula but different structural arrangement. But now we cannot now start drawing all of these, for we to determine isomers, start drawing the structures of this compound to know how many isomeric form will come out from this. There is a formula that should be applied. That is why you must listen carefully. So moving further, to determine the numbers of isomeric form of this compound is actually very easy. What does this question ask us to do is to, is asking us how many times can we draw this compound that we are to get the same molecular formula. It is simple. Listen carefully. That is why you have to have the in-depth knowledge on the topic isomerism. I think what I will do here is just to maybe leave this question and then create a full video lesson on the topic isomerism, because if I want to start solving it, I have to take it step by step so that everybody here can understand how this question can be solved. It is extremely very easy. So let's just quickly go over to the next practice question. Now, moving further, the next question says, stainless steel is an alloy of. What are alloys generally? You must understand here that alloys are simply metallic mixtures, meaning that they are mixture made up of different metals. And one of the major elements or metal found in stainless steel is iron. Are you there? There is another which is CrO. It's called chromium. And the last is nickel, Ni. But you must understand here that the base element is iron. Are you there? Base element means the major of them that forms this stainless steel is iron. This must be noted. So let's go over to the next practice question, which is, what is the basicity of H2SO4? Now, H2SO4 basically is an acid, and when we dissociate it, meaning when we break down this compound, we are to get this, which is H plus SO4 2 minus. And this reaction is not yet balanced because we have two hydrogen here. So definitely here should be two hydrogen as well, whereby one sulfur, four oxygen. The charges doesn't really matter here. So what is basicity? Now, this is an acid. So what is basicity of an acid? It is simply the number of replaceable hydrogen ion found in one molecule of an acid, meaning that at the end of breaking that acid, how many H plus are we going to get? So at the end of breaking this, how many H plus did we get? Got 2. That means this compound basicity, this compound's basicity is 2, or we can as well just say it is dibasic. I believe you are following. It is extremely very easy. So what you just have to do here for me is to simply name this compound and provide the answer in the comment section. To determine number of isomeric form, I'm going to explain the full video lesson. Though I don't have to just put the answer. It's not just by knowing that this is the answer, because they might give you another question with different compounds, so you have to know how it's solved. That's why I'm not solving it right now. I'm going to solve it in another video lesson, like in a full video lesson on isomeric. So watch out for that video. So the question here now is to name this compound. Provide the answer in the comment section. It's simple, like ABCD. Identify. What are the steps? Identify the longest continuous carbon chain. After identifying it, number it. After numbering it, name it. And note your substituent. Don't rush. It is very, very easy. You understand? It's so much very easy. And if you observe how many carbons are here, there are 3 carbons. So this tells us that the parent name should start with prop. And they are all single bonds, so it should be an alkane, so definitely it should be a propane. So finish it. So moving further, question 8 says, a solution with pH greater than 7 is what? Very simple. You know, in the pH scale ranges from 0 to 14. You understand? And now, between 0 and 14, there is a number which is 7. So when we have values in the pH scale that range from 0 to about 6.9, downward, we say that solution is acidic. But if it ranges between 7.1 to 14, we say that that solution is alkalinic in nature. Are you following me? So you can see that we said that the solution's pH is greater than 7. Is greater than 7 means that it is alkalinic. If it was 7, we say that that solution is neutral. I believe you are following. It is very, very easy. So let's go over to the next practice question, which says, when a metal forms an hydride, what specifically is that hydride? Very simple, because now we have different types of hydride. We have a scenario whereby hydride will be formed from a metal with, from the word hydride, that means there is hydrogen. Metal and hydrogen, it gives us an hydride. We also have other cases whereby we form a non-metal will combine with hydrogen as well. It's also form another types of hydride. So all this must be noted. So you must note here that when a metal reacts with hydrogen, it forms an hydride that is called ionic hydride. Note that. Please note what I just said is very, very important. Whenever metals react with hydrogen, the hydride that is formed is an ionic hydride. Though there are deeper explanations to all of this, but it's important to just know what I've said. So moving further, if it's a non-metal that combines with hydrogen, the hydride that will be formed is a covalent hydride. Are you there? Is a covalent hydride. So this must be noted. So moving further to the next question, which says, what are amphoteric oxides? Amphoteric oxides are oxides that behaves like acid and as well behave like a base. They have both properties of acids and properties of bases. There are some elements that actually forms amphoteric oxides. From the word oxide, it means that the element will combine with what element? Majorly oxygen. And we have some key elements that combine with oxygen to form amphoteric oxide, like zinc, like aluminium. These guys have tendency to actually form what we call amphoteric oxides. I believe you are following. Is very, very simple. So let's move over to the next practice question, which says, the ability of a metal to be sonorous. What does this mean? This is one of the characteristics of metals. Metals have so many characteristics, like having high melting and boiling point. They are malleable, they are ductile, they are sonorous. So for them to be sonorous, it means that they can give off musical notes when beat upon. You understand? So this must be noted. When you hit metals, it gives musical notes, and that is called sonorous ability of a metal. So moving further, malleability of metals means, so this is another property of metal because metals are malleable. So malleability of metal means that we can actually take a metal and beat that metal into a flat sheet. You understand? When you take a metal, you can beat it into a flat sheet. This is what we mean by metal being malleable. There are other characteristics of metals, like metals are hard but not brittle, means that they are hard, you can't easily break them. That's what brittle, you can break them easily. You understand? So moving further, an organic compound with the arrow OH functional group is likely to be an alcohol. You understand? Any compound with the OH functional group called the hydroxyl functional group is called an alcohol. So this must be noted. Moving further, let's get into the next practice question, which says discovery of atomic number was by who? Was by a man called Henry Moseley. This must be noted. And let's go over to question number 15. It says the ability of an acid to react with a base to form salt and water. This is a very popular reaction and it's called neutralization reaction. This is the ability of what? An acid to react with a base to form salt and water. Let's get into the next practice question. Moving further, let's get into the next practice question, and it says discovery of cathode ray was by who? Very simple. Cathode ray was discovered by a scientist called William Screw. This must be noted. Note this. It can be a possible question that will come out in your Jamb exam, whereby question number 17 says discovery of X-ray was by who? It was discovered by a man called Wilhelm. It's not Williams now. Wilhelm Röntgen. This is why the X-ray is also regarded to be called the Röntgen's ray. Take note of that. It was named after the man's second name, all right? So moving further, 18 says, the term used to describe a compound that lost their water of crystallization to the atmosphere is called, very simple. Now, we have a compound. Now, how do we know this? We have compounds with water of crystallization like this, Na2CO3.10H2O, for instance. This set of compounds with water of crystallization, they are called fluorescent compounds. They are compounds with water, and when you expose this compound to the atmosphere, they tend to lose their water. So there is a term that describes that, and it is called efflorescence. Are you there? Efflorescence is the answer to this question, and it is different from what we call effervescence. Effervescence has to do with the bubbling of gases. You understand? As seen in the first question, where I used Coca-Cola drink as an example, whereby the Coca-Cola drink was opened, the gas that just came out, which is the CO2 gas, the process is called effervescence. Are you getting the point? Because it has to do with the bubbling of gases, is different from efflorescence. So moving further, that substance that dry all gases, that substance is called silica gel. This must be noted. Now, this also must be noted. These questions are on non-metals and metals as well. Now, the question says, dash bonds with a pale blue flame. Wow. So it's a confirmatory test for a particular non-metal. It bonds with a pale blue flame and make a pop sound when burning. That particular gas is called hydrogen gas. Take note, you must always understand that hydrogen gas is a gas that bonds with pale blue flame and makes a pop sound when burning. Now, moving further, the gases used in fountains experiment, there are two majorly. We have ammonia, which is NH3, ammonia gas, and as well as acid. Now, why are these gases used during this experiment? They are used, that's question number 23, they are used because they are very soluble. They are very soluble. That is why they are used in this experiment, because this experiment works with compounds that are very, very soluble. Now, moving further, it must be noted here that alkaline pyrogalol and as well as heated copper, these are compounds that absorbs or dries a particular type of gas, and that gas is oxygen gas. Please note this, these are possible questions on metals and non-metals you should watch out for. Now, moving further, here are some other processes. All these processes are industrial processes used to form different types of compounds. When you hear about Haber's process, it is an industrial process used in the production of ammonia, which is NH3. Are you there? And the catalyst used here is called finely divided iron. What is a catalyst? That would be the question that ask yourself. A catalyst is simply a compound that speeds, not just a compound, a catalyst can be an element or a compound. You understand? That speeds up the rate of a reaction. So catalyst helps to produce more, like it helps to speed up the rate ammonia can be produced. You understand? In the process, Haber process. For contact process, the is an industrial process used for the production of H2SO4. This is what we call contact process. For flash process, it is a process used during the extraction of sulfur. These must be noted. Moving over to Atkins process. Atkins process is a process used during the production of a very, very important allotropic form of carbon, which is called graphite.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the Jamb exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
Remember, graphite is what? Is it an amorphous allotrope of carbon or a crystalline allotrope of carbon? It is a crystalline allotrope of carbon. You understand? And this has an hexagonal type of shape. You understand? We also have another crystalline allotrope of carbon. Do well to mention that in the comment section. There are two major. One is graphite, and the other is what? Mention that in the comment section. For Ostwald process, is the process used during the production of this compound, which is HNO3. Moving further, for solvent process, is the process used to produce what we call soda ash, Na2CO3. This is what we call soda ash. That's the common name, but we can call it sodium trioxocarbonate 4. I'm still going to create videos on how to name all of these types of compounds. They are very easy. So moving further, the catalyst used in contact process is V2O5. The element V is vanadium and O is oxygen. So this should be pronounced as vanadium 5 oxide. Are you there? It's simple. Vanadium 5 oxide is the catalyst used during the contact process. Moving further, let's get into the question 32. It says, the chemical formula of POP is what? First of all, what's POP? POP is called plasters of Paris. This is a cast used to hold broken bones in the hospital. You understand? Now, this guy, which is POP, has this chemical formula to be calcium sulfate dot half H2O. This is the chemical formula of, plasters of Paris. You can see it has water content in it. You understand? Moving further to question number 32, it says, what is the chemical formula of lime water? Lime water is simply calcium hydroxide bathed in water itself, which is H2O. So this is the chemical formula. So it's actually not just a chemical formula, it's like a mixture. Do you understand? This is lime water. It is simply calcium hydroxide and water itself. It forms lime water. So let's get into the next practice question. Moving further to the next practice question, which says, that substance absorbs CO2. There are two major group of compounds that have the ability to trap CO2 as a gas. They are sodium hydroxide and as well as potassium hydroxide. These are the compounds that can do that. They don't only trap or absorb CO2, they can also trap or absorb SO2 as a gas as well. So moving further, you can see all of these are list of alloys. Remember, I said that alloys are metallic mixtures, meaning that they are mixtures made from metals, metallic mixtures, and all alloys have a base metal, the most important. That's what base means. So duralumin is an alloy of what? Very simple. One of the major base metal. The base metal will be written first, so you note that. So aluminium is one component of duralumin, and it is the base metal. Others are copper, manganese, Mn, and magnesium. These are the components of duralumin. Is a metallic mixture made up of different metals. So for bronze, it's very simple. It is copper that is the base metal, and the other one is bronze. So here is tin. There's a way you actually used to just note that, but please note this, it's very, very important. For brass, the base metal is still copper. You understand? But now it is zinc, Zn. Moving further to the next question, which is question number 38, it says, ordinary steel is an alloy of. Now, whenever you hear steel, the base metal of made all major the base metal of steels generally, most steels generally is simply iron. So whenever you see anything that ends with steel, be it ordinary steel, be it manganese steel, be it tungsten steel, there are so many, molybdenum steel, okay, you just know that all of these are elements combining with this steel, and the base metal is iron, you understand. But for ordinary steel, the other element is carbon. But for manganese steel, the other element is manganese as an element. Are you there? So moving further to the other alloy, which is question number 39, which is permalloy. It is made up of nickel and as well iron. Are you there? So, but in this case, nickel is the base metal. Are you following me? It is very, very simple. It is not difficult. So we've come to the end of this practice question. If you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share my videos with your friends. Thanks for watching.